All right, let's get started. A relation. A relation is a set of ordered pairs. Remember, an ordered pair, or like a point, looks x comma y, where there's one value comma a second value. We're talking about relations or groups of those sets of those ordered pairs. There's several ways we're going to look at illustrating and demonstrating these relations. One such way is mapping, and a mapping um, illustrates how um, elements in the domain relate to the range. The domain and the range, these terms hopefully sound familiar. The domain is the set of the first numbers of the ordered pair, and the range is the set of second numbers of the ordered pair. So the domain is all those, the first numbers, we can think of those as the inputs. The range is a set of second numbers, we can think of those as the outputs. Now, I said there's several ways of showing these relations other than just listing the set of ordered pairs. So if we looked at this relation here, we have the set 2, 5, negative 2, 3, 5, negative 2, and negative 1, comma, negative 2. I'm going to do the easiest one first, which is to show this in a table. So the table, we take each of these ordered pairs and put them in a row. So with the x's in the x column and the y's in the y column. So we take 2, 5, negative 2, 3, 5, negative 2, and negative 1, negative 2. So we put this in a table. Great. Now let's look at putting it as a mapping. So the mapping, I'm going to essentially take my x column and copy it over. So I'm going to take 2, negative 2, 5, and negative 1. Now, in the range bubble, if we will, you cannot, also in the domain bubble, you cannot and should not, will not, repeat values. So notice 2, negative 2, 5, and negative 1 are all unique. So now I'm going to put in my y values. So 5, 3, negative 2. My other value is already a negative 2, so I'm going to leave it there. So with my mapping now, I'm going to take from the domain and draw an arrow to the element with which it corresponds in the range. So 2 goes to 5, negative 2 goes to 3, 5 goes to negative 2, and negative 1 also goes to negative 2. Now, graphing. We have a coordinate plane here with our x-axis going horizontally, our y-axis going vertically. We're going to plot these points on the coordinate plane. So I'm going to go 2 is my movement along the horizontal x. I'm going to go 1, 2, and up 5. 1, 2, 3, 4, 5, and that point lives there. I'm going to go negative 2, 3, which means I'm going to go negative 1, 2, and up 3. 1, 2, 3. I'm going to go 5, negative 2, which means I'm going to go 1, 2, 3, 4, 5, and down 2, 5, negative 2. And I'm going to go negative 1, negative 2. So there my relation is graphed on a coordinate plane. Now, I'm going to identify what is the domain and the range. When I identify these sets, it is tradition to put them in least to greatest value. So my domain would be negative 2, negative 1, 2, and 5. And my range would be negative 2, 3, and 5. Let's look at another example of a relation that we can put in multiple forms. So we have the point 4, negative 3, 3, 2, negative 4, 1, and 0, negative 3. So I'm going to put it in my table first for negative 3, 3, 2, negative 4, 1, and 0, negative 3. Let's graph it this time. So 4, 1, 2, 3, 4, and down 1, 2, 3, and 3, 1, 2, 3, and up 2. Remember, you always go in your x direction first, and then up or down in the y direction. Negative 4, 1, 1, 2, 3, 4 in the negative direction, up 1, and then 0, 3. So I'm going 0. I'm not going anywhere in the x direction, but down 1, 2, and 3. All right, so let us now look at our map. So we put in our domain. So 4, 3, negative 4, and 0. We put in our range, not repeating any values. Again, the domain didn't repeat any values. The range, we're not going to repeat any values. So we have negative 3, 2, and 1. And we already have negative 3. And now we're going to draw the line to where it connects. So 4 maps to negative 3, 3 maps to 2, negative 4 maps to 1, and 0 maps back up to negative 3. All right. And our domain in numerical order goes negative 4, 0, 3, 4. And our range goes negative 3, 1, 2. All right, let's talk about some of these parts of the domain and the range and other important aspects of relations. When we start talking about relations, we deal with the independent variable. The independent variable in a relation is the value of the variable that determines the output. So the variable that determines the output. Or think that this is your input. A dependent variable is that variable that is dependent on the other value. So it's the variable based on or dependent on the input. Or think that this is our output. This dependent variable will change based on what the independent variable is. You cannot plug in a dependent variable. If you are going to change a variable, change the value of a variable, you are changing the independent variable. So let's look at some scenarios and identify what the independent and dependent variables are. So if the air pressure inside of a tire increases with the temperature. So let's think, if the air pressure goes up when the temperature goes up, or the air pressure then also would go down when the temperature goes down, what is causing another thing to change? Our independent variable, the change, is going to be the temperature, and our dependent variable is going to be the pressure. Let's think, as the amount of rain decreases, so does the water level of the river. So if we get less rain, the water level goes down. If we get more rain, the water level goes up. So what is the variable that determines the output? What determines another's fate? The amount of rain. And what then is affected? The water level. For our practice problems tonight, we are looking at page 188, numbers 9, 10, 11, 15, and 16. Now, for 9, 10, and 11, it asks you to express each relation as a table, a graph, and a map, and then determine the domain and the range. All right? Remember certain things like the mapping never has repeated values. The domain and range are in number from least to greatest. All right? Have fun.